So, and then time analysis, meaning that each activity, what time you need to take, like certain activities, certain procedures, it needs time. Like I said, you cannot bake a cake, like you put it in the oven for 10 minutes and then you expect it to cook, if let's say the recipe calls for 15 minutes. So, in order to achieve a fluffy, nice, beautiful cake, you need to go through it carefully. It's a systematic procedures. It is not an art of throwing everything into the bowl and then it will come out, or throwing everything into a bowl and into the oven, it will come out as it is. I mean, there are some that are like that, but not many, you see. And then how much money you spend on the material, also spend on the machinery also will have a difference, you see. A handheld mixer and a mixer that is used for a strong mixer, and a good quality butter, high quality butter is different. So we need to know the requirement first, like what is expected from your audience. Let's say your audience are just buying $1 3-piece kind of cake, and somebody who is going to eat like one cake $11 or $20. It's a complete different audience, and that is what we call by customers requirement. So I hope this simple example can show you, how we can think of quality management for our work. I mean, to me, I think, I'm a good baker because I am actually an engineer. I think all engineers can be very good baker because we will go through the procedures very carefully, step by step, and we'll plan our recipe step 1, step 2, step 3 very carefully because we are trained to do that. And in each of the section, we will take note of what is supposed to come out from here, and then if it doesn't, what can you do to save it? What can you do to, or you didn't need to redo everything at this stage, at stage A, earlier stage. If you need to redo it at earlier stage, it's better than if you redo and rework and do everything again when it's already totally spoiled and you have already whole $50 of ingredients in there, or 500,000 of ingredients in there, So you better off, like, let's say, if it's nothing that you can do to save it, then your plan B should be abandon it, like abort it and start fresh, start all over again. So it's the same thing, like mixing concrete, bar bending, doing a lot of construction activities. It's that simple as well. It's that simple. You don't think of it as too complicated. So you get your work breakdown structure out. And then from there, list down the work method, work procedures, and from the work procedures, list down what is required from certain parts of the procedures. Show us how important to achieve certain acceptance criteria. It has to be some acceptance criteria, preferably some numbers or some rubrics. Not if we don't achieve that, what do we do? And then what about the resources? What is the resources required? What are the machinery calibrated, to what standards, and then the resources, the material to what standards, or what type of material, grade 30, 35 concrete grade, 30 concrete grade, 40 concrete grade, 50 concrete, they are all different. So you need to know their nature, their characteristic when you do that requirement. So they are all requiring time, they're all requiring resources, they're all requiring proper sequencing of activities. So they're all interrelated with one another. So the detail will increase when you have more information here, you see. And so this project quality plan, we normally would also use things like cost benefit analysis. I mean, why do we use cost benefit analysis? Because when you design certain steps and certain procedures, certain resources, you have to understand that what benefit it will bring. Would it create a better result, compared to if you spend this amount of money and then, you may get a good result, but it's not as good, but the value of it is completely different, you see. So cost benefit analysis is also part of the techniques, or part of the skills that you need to have when you want to make decision on the level of quality. Benchmarking, of course, to look at other product in the market, other people's doing work, other people's work method statement, other people's testing requirement, other people's way of building up an experiment. Like what I mean by building up an experiment, like for example, if you're going to do water pipeline testing, how do you fix the pressure into the pipeline, and how do you read, and how do you tighten, and all these are all experimental work in a way. So you need to know the procedures, so design procedures using flowchart. Flowcharts, like I mentioned just now, is quite common to use flowchart, design of experiment, yeah. So these are quality quality parts of the quality requirement that you need to put down. I mean, these are the techniques that we can use. Not all of them you need, depending on the project, but some of it you can use experimental work, you can use testing work, you can use benchmarking, looking at other products and see how you measure up. Then you can also use a flowchart, checklist, or a table format. In order, flowchart table, I think you can use in one way or another, depending on the level of detail that you're looking at, So table, you can have different sections of the table, and then activities, and then the requirement, and then the output, and then from the output, what is it that you say yes to the output or no to the output? If it's no, then you go to step number what, So these are table kind of way of doing it as well, procedurally way of doing things, doing a manual as well. So a PQP is a very important document, and a lot of engineers are currently in this industry. It's very sad that we don't take it too seriously. A lot of us get as a consultant, instead of designing your own project quality plan, you leave it to the contractor to work out a work method statement, and the contractor to work out a work method statement. They would not want to be serious about work method statement. And also the other thing is, a lot of designers like to treat a quality plan as specifications, as specs. Specs is only one document. Specs is only part of it, not everything. Specs is like, for overall, for generally, for concreting work, we need this standard, we need to meet this standard. Yeah, that is specification. But it doesn't tell you the procedures. It doesn't tell you what should go into it. It doesn't tell you how to detect problems. It doesn't tell anyone, it doesn't tell the site people, if you see, this color, if you see this deviation, you cannot accept it. So hardly specs write like that. So a lot of you actually will experience the fact that you don't write your own specs. You just go and take specs from previous projects that is 20, even 30 years ago, and try to use that as a specification. And how accurate can they be? So don't take PQP or QMP as spec, as work method statement that is done by contractor. It's not. It's a combination of everything. Specs only tell you certain requirements and certain, they don't spell out the entire, they spell out the requirement, but they don't spell out the steps for you to go up, and they don't spell out, a lot of times they don't spell out the acceptance criteria as well. Okay? Some may, maybe concrete cover and all the common one, yes, but some detailed one, they don't specify. Okay? They don't specify how it should be at the end of the day. Okay? And then drawings, match with specs, with BQ, these are only part of, to me, it's only part of costing work. You use this document for costing work, but PQP, you only use all this as supporting document. You need to create a proper PQP. In the PQP, not only the plan, you need to create the checklist, the matrices, the rubrics, for people to, it's a plan that anybody, your workers, your supervisors can pick up, your engineers can pick up, and then they can proceed to do the things that needs to be done. So baseline is also quality baseline. It's like the how much is accepted. If cover 20 is accepted, if it's plus and minus 2 mm, is it acceptable? If it's written there 20 plus or 2 plus or minus 2 mm, then that is acceptance criteria. That is your baseline, you see. And then if let's say you can't achieve that, what do you do next? That is the improvement plan. And how do you have to checklist? Matrices is like the numbers. What numbers are we looking at here? Are we looking at millimeter? Are we looking at colors? Are we looking at smoothness? Are we looking at pressure? Are we looking at deviation? What kind of deviation in terms of what matrices? What sort of measurement that we are looking at? So it's like the processes, the procedures, the practices, the matrices, the checklist, the how do you make it? What is plan B? What is the improvement plan? What is the acceptance criteria? The baseline. So these are the important information that you must have, for your PQP. See, so that is PQP, not just work method statement. Work method statement is only how the work is proceeding. Specification is these are the requirements according to what standard. That's it.